Ever since speed skating was recognized as an Olympic winter event in 1924, it has been defined as a dangerous sport. The top skaters in the world can reach a speed up to 50 kilometers per hour, wearing nothing but a helmet, a skin-tight suit, and specialized skates. With this immense amount of speed, one must have good technique to harness the speed and stay in control. However, good technique is not the only factor that contributes to a safe and rapid skate. Without the physics behind the special equipment and certain forces acting in different areas of the race, the entire sport would change. As the skaters line up to begin the race, they dig their front foot into the ice with the tip of their skate and plant the back foot behind them using the entire blade. Since the skaters are completely at rest with a velocity of 0, all of their energy is in the form of potential energy. Once the whistle blows, the skaters push back on the blade of each skate and accelerate forward, with the magnitude of the acceleration dependent on the amount of force exerted by the blade on the ice. At this point in the race, the potential energy is being converted into kinetic energy, while the skater accelerates down the track. As the skaters glide down the straight part of the track, they are constantly accelerating, gaining momentum, which will become very important once they reach a turn. Just before the track begins to curve, the skaters are at their maximum velocity, meaning all of their energy is now kinetic. Skaters must make their strides much smaller to navigate the turn, meaning they are unable to move as fast and will benefit from the momentum acquired earlier in the race. Once the curve is reached, the skaters seem to lean towards the center of the rink, which is caused by the centripetal force, pushing them toward the middle of the track. While skating, the skate blades create shallow grooves in the ice, which help the skaters glide more smoothly and stay balanced, while moving forward in a fluid motion. A centrifugal force directed toward the outside of the track is then exerted to counteract the centripetal force on the blades, pushing the skates slightly out of the grooves in order to keep the skater turning. If the skater was to move out of the grooves completely, they would fall. If we look at this free body diagram, we can see that the ice exerts a force that can be separated into components. There is a component parallel to the ice, which is a static friction force where the skate blades cut into the ice. The ice also pushes up perpendicularly, exerting a normal force. In speed skating, the ice needs to be low in friction in the direction the skate moves, and high in friction perpendicular to the blade. By taking the centripetal and centrifugal forces into consideration and finding the perfect angle of lean, skaters are able to successfully navigate curves swiftly and safely. The equipment used by speed skaters is very crucial in winning any race. The equipment that most affects the speed of the skater are speed skates and skin suits. In comparison to figure and hockey skates, which lace up the leg, speed skates look more like athletic shoes. They have much longer blades, which are designed specifically for speed and are cut in a certain shape for their use. The German design is called a clap skate, where the shoe is connected to the blade using a hinge that allows the skater to increase his or her speed and acceleration by keeping the blade on the ice for a longer period of time. Clap skates were first introduced in 1996, being referred to as machines on ice. At first, most were angry with this new skate design, and a lot of the most elite skaters wouldn't touch them, saying that it was impure and an abomination to their precious sport, since it gave such a huge advantage. The skate blade wasn't fixed in a position at all, and could rotate independently from the entire shoe portion. The skate was created to allow athletes to have full ankle extension and generate more power from the knee, helping them to keep their balance easier and prevent injury. With the old skates, pushing up onto the front of the skate's blade meant that the skater's knee was absorbing a tiny bit more of his or her energy, about 5%, which is pretty small but just enough to make a big difference out on the rink. The introduction of the clap skate was revolutionary in the speed skating world, as it took only 2 years from the perfection of the design to cut 2 seconds off a world record. After multiple records were broken, almost all long track skaters had made the switch to the clap skate. The skin-tight suits are also important for the skaters to obtain the fastest time possible. Most long track skin suits are made with hoods and special material such as nylon, spandex, and polyester, specifically designed to reduce wind resistance and drag. This makes long track suits more aerodynamic and increases skaters' overall speed. Short track skin suits are designed to give speed skaters comfort and maneuverability. There has been a large amount of controversy around skin suits, specifically at the 2014 Sochi Winter Olympics. Under Armour had designed a new suit for the U.S. speed skaters called the Mach 39, which they claimed to be the fastest suit ever designed. The bodysuits were made from a dimpled polyethylene material designed to divert air drag, and designers placed a large lattice vent in the back of the suit to let the athletes' bodies breathe. Athletes claimed that the vent allowed too much air to enter the suit, creating a vacuum behind them that slowed their speed. Having no U.S. skaters medal that year, Under Armour made a significant improvement to a new suit with no vent and 3 textured fabrics stitched together. The suit has miniature pockets in the fabric on specific parts of the body, such as the arms and legs, that are particularly troublesome since wind tends to wrap around them, creating vacuums that can slow skaters' speed. Speed skating equipment has improved the speed of skaters drastically since the sport's origin. These improvements have had a huge societal impact by creating a much more competitive and exciting atmosphere at events such as the Winter Olympics. With more agile and speedy athletes competing, citizens from all over the world have become more engaged and have more fun cheering on the skaters from their home country. Events such as the Olympics encourage national pride and push the skaters, and therefore the manufacturers of the equipment, even harder. Speed skating equipment also pertains to the ice rinks that are required for the sport to take place. The skaters are dependent upon the cooling equipment beneath the track itself. Ice rink refrigeration is a complex system meant to precisely keep temperatures appropriate to the needs of each facility. Chemical agents traditionally chosen to accomplish these tasks have very high toxicity levels and volatile characteristics. Traditional coolants, such as ammonia, have been proven in research studies to have negative impacts upon the environment, the ice rink equipment, and energy consumption. In order to protect the environment and maximize energy output, CO2 ice rink refrigeration has become the preferred innovative method for cooling ice rinks across North America. As many as 8 kilometers of twisted and wound steel piping can exist underneath a single ice rink. This implies that a significant impact is made upon the environment when toxic waste from these materials is released. Additionally, CO2 ice rink cooling systems require far less maintenance and can use as little as half the energy used with traditional coolants. The careers related to speed skating equipment include materials scientists and engineers who design and perfect the suits and skates that athletes wear. They also include the manufacturers and suppliers who take these designs and turn them into real items that can be put up for sale. Lastly, they include the professional skaters and coaches who use the carefully crafted equipment which maximize speed and minimize air resistance to win competitions.